In simple, if you can explain me what are sodium-ion batteries?
Sodium-ion batteries are like lithium-ion batteries, but use sodium instead of lithium. They store energy by moving sodium ions between a cathode, usually made of materials like sodium metal oxides, and an anode, often carbon-based. You charge, sodium ions flow to the anode. When you use the battery, they move back to the cathode, releasing energy. Think of it like a bucket brigade. Sodium ions are the buckets passing energy back and forth. They're cheaper and safer than lithium-ion batteries because sodium is super common, but they're still being improved for better performance.
What is cathode and what is anode? In simple terms, what does it mean?
All right, let's break it down. In a battery, like a sodium-ion one, the cathode and anode are the two main parts where the action happens. Cathode is the positive side of the battery. It's where sodium ions go. You use the battery. Think of it like a magnet that pulls the ions in to release energy. It's usually made of something like sodium metal oxides. Anode is the negative side. It's where sodium ions are stored when you charge the battery. Picture it as a storage tank that holds the ions until you need power. It's often made of carbon materials, like graphite. So, ions flow from anode to cathode when you use the battery.
Why is sodium-ion battery considered better than lithium-ion?
Sodium-ion batteries aren't necessarily better than lithium-ion, but they have some big advantages that make them exciting. Here's the deal. 1. Cheaper and abundant. Sodium is everywhere, like in table salt. It's way more common and cheaper to get than lithium, which is mined from specific places, costs more. 2. Safer. Sodium-ion batteries are less likely to catch fire or explode compared to lithium-ion. They handle heat and damage better, so they're safer for things like electric cars or home storage. 3. Eco-friendly. Since sodium is abundant, it has less environmental impact than digging up rare lithium and cobalt used in lithium-ion batteries. There are differences that hold sodium-ion back for now. Sodium-ion batteries store less energy per weight than lithium-ion. So for the same size, a lithium-ion battery might power your phone longer.
So sodium is similar to table salt. Is it very different from that?
Talking about whether sodium batteries is like table salt. It's not exactly the same, but they're related. Table salt is sodium chloride, a compound made of sodium chlorine. Sodium batteries, we use sodium in a different form, usually as part of materials like sodium metal oxides or sodium salts in the electrolyte. Table salt is like sodium's cousin. The sodium batteries is pure or combined with other stuff to make energy flow, not something you'd sprinkle in fries. You can't just grab table salt from your kitchen and make a battery. It needs to be processed into specific forms. But the big deal is sodium's abundance, like in salt, makes it cheap and easy to source.
What is sodium connected to? It is table salt. What it gets connected with so that it becomes useful in a sodium-ion battery.
Sodium in sodium-ion batteries, just table salt, sodium chloride from your kitchen. To make it useful in a battery, sodium is combined with specific materials that help it store and move energy. Here's how it works in simple terms. In the cathode, sodium is often part of compounds like sodium metal oxides, sodium iron phosphate, or sodium cobalt oxide. These are like hosts that hold sodium ions and let them move in and out to create energy flow. In the anode, sodium pairs with materials like hard carbon or graphite. When the battery charges, sodium ions get stored in these materials, like parking them in a garage. In the electrolyte, sodium is used in a sodium salt, like sodium hexafluorophosphate, dissolved in a liquid. This lets sodium ions shuttle between the cathode and anode, carrying the charge. Sodium isn't used alone, it's chemically combined or processed into these special materials to make the battery work. Think of table salt as sodium's starting point. Scientists tweak it into fancier forms for energy storage.
Is there a better example for this?
Think of a sodium-ion battery like a sandwich making station. Sodium ions are like the sandwich fillings, say cheese, they move around to create the energy. The cathode is like one slice of bread. It's made of something like sodium metal oxide, holds the sodium ion. For example, sodium iron phosphate is a common cathode material. It's sodium mixed with iron and phosphorus to make a stable structure. The anode is the other slice of bread. It's usually made of carbon, which grabs and stores the sodium ions when the battery is charging. The electrolyte is like the mustard or mayo spread. It's a liquid with sodium salts, like sodium hexafluorophosphate, that lets the sodium ions slide easily between the anode and cathode, holding the sandwich together. Scientists take sodium and mix it chemically with others like iron, phosphorus, or carbon to create materials that can catch and release sodium ions. When you charge the battery, sodium ions move to the anode. You use it, they zip back to the cathode, the other slice, making electricity flow. Table salt itself won't work because it's locked up with chlorine. Instead, sodium is freed up and blended into these special compounds, like the star player in this energy game.
Are these batteries rechargeable? Are these batteries similar to lithium-ion batteries? Sodium-ion batteries work.
Sodium-ion batteries work like lithium-ion batteries, but use sodium instead. They have two electrodes, an anode and a cathode, with an electrolyte in between. When charging, sodium ions move from the cathode to the anode through the storing energy. When discharging, those ions flow back to the cathode, releasing energy to power your device. Think of it like a bucket brigade. Sodium ions are the buckets passing energy back and forth. The key difference from lithium? Cheaper and more abundant, but the batteries are often bulkier.
How bulky is the battery? If I'll be comparing a lithium-ion battery of the same wattage or power, How is it different from sodium-ion batteries?
Sodium-ion batteries are generally bulkier than lithium-ion batteries for the same power wattage. Here's why. Sodium ions are larger and heavier than lithium ions, so the materials needed to store and move them, like the anode and cathode, take up more space and volume. For example, if you have a lithium-ion battery that's 100 hours, it might be smaller and lighter than a sodium-ion battery. A sodium-ion battery could be roughly 20 to 30% larger in volume and maybe 10 to 20% heavier, depending on the design. Sodium-ion batteries use cheaper, more abundant materials, so they could cost less.
So sodium batteries, future, will they be used in phones as well?
Yeah, sodium-ion batteries could totally work in cars, and they're being explored for that because sodium's cheaper and more sustainable than lithium. For example, some companies are testing them in electric vehicles. Cost matters more than size, like budget EVs. Phones, though, trickier. Phones need a compact, lightweight batteries, and sodium-ion batteries are bulkier and heavier for the same power. Size isn't a deal breaker.
So in terms of energy density, if I want to understand sodium ion compared with lithium ion, what is the difference?
Energy density is how much power a battery can store in a given size or weight. Lithium-ion batteries have higher energy density than sodium-ion batteries. For example, a lithium 250 watt-hours per kilogram, while sodium-ion batteries are typically around 100 to 150 watt-hours per kilogram. This means a lithium-ion battery can pack more power into a smaller, lighter package, great for phones or EVs where space matters. Because sodium ions are bigger, store less energy for the same weight or volume. Lithium ion fits more, while sodium ion needs a bigger bag for less. Cheaper materials.
How cheaper is the material if I consider sodium ion, lithium ion? Give me the pricing per kg of lithium and 1 kg of sodium.
Exact prices for battery grade materials fluctuate, but I can give you a rough idea based on raw material trends. Lithium-ion batteries use lithium, cobalt, and other pricey metals. Pure lithium metal costs around $100 to $200 per kilogram, but processed lithium compounds for batteries, like lithium carbonate, run about to $30 per kilogram. Cobalt and nickel can jack up costs further. Sodium-ion batteries use sodium, which is dirt cheap. Sodium compounds like sodium chloride cost less than 1 cent per kilogram. Even processed sodium for batteries might be to $5 per kilogram. Lithium-ion packs are pricier, maybe $100 to $150 per kilogram of battery, due to materials and processing. Sodium-ion batteries could be 30 to 50% cheaper, so roughly $50 to $100 per kilogram, since sodium and common materials like carbon or iron are abundant. Lithium-ion battery costs roughly $100 to $150 per kilogram to make, including materials like lithium. Sodium-ion battery costs roughly $50 to $100 per kilogram, using cheaper sodium and more common materials like iron or carbon. The difference is around to $50 cheaper per kilogram. Lithium-ion. If a lithium-ion battery is $120 per kilogram, a sodium-ion might be $70 per kilogram, saving you about $50 per kilogram. These are rough numbers. Prices depend on scale and tech, but sodium-ion's materials are way less expensive.
Are there any companies right now who are actively working on sodium?
Yeah, several companies are diving into sodium-ion batteries. For example, CATL, the world's biggest battery maker, announced sodium-ion prototypes for aiming UK, developing sodium-ion tech for various uses, like vehicles and storage, focusing on low-cost designs. Tiamat, France, a startup working on sodium-ion batteries for mobility and grid storage, with some cool prototypes. Natron Energy, US, specializing in sodium ion for data centers and heavy equipment, already shipping some products. These guys see sodium's potential for cheaper, sustainable batteries, especially where size isn't a huge issue.
Are there any heating concerns related to sodium ion batteries?
Sodium ion batteries are generally safer than lithium ion when it comes to heating concerns. Lithium ion batteries use flammable electrolytes and can overheat or catch fire if damaged or overcharged. Think of rare phone or EV fires. Sodium ion batteries often use less flammable materials, like aqueous or solid electrolytes. Sodium, they're less likely to go into thermal runaway, where heat spirals out of control. For example, punctured lithium, a sodium ion typically just fizzles out. That said, sodium ion designs aren't perfect. Heat can still build up during fast charging, but the risk of catastrophic failure is lower. Yeah, fast charging can work for sodium ion batteries, but it's not quite as slick as lithium yet. Lithium ion batteries are optimized for fast charging. Think 20-80% in 15 to 30 minutes in modern EVs or phones, because lithium ions move quickly through their electrodes. Sodium ion batteries can fast charge too, but since sodium ions are bigger and heavier, they move a bit slower, so charging might take longer for the same capacity. For example, some sodium ion prototypes hit 80% charge in 30 to 40 minutes. Cutting edge lithium ion can do it in half that time. With better materials, like improved electrolytes, sodium ion could catch up. Sodium ion tends to handle heat better during fast charging, so it's safer. Curious about how this impacts something specific like EVs?
You said sodium ion manages heat better. What is the reason for that? And how is it different from lithium ion?
Sodium ion batteries manage heat better than lithium because of their chemistry. Sodium ions are larger and less reactive than lithium ions, so they don't trigger as intense chemical reactions when stressed, like during fast charging or damage. Lithium ion batteries use flammable liquid electrolytes that can ignite if overheated. Sodium ion batteries often use more stable electrolytes, sometimes water-based or solid, which are harder to ignite. Also, sodium's electrodes, like those made with iron or carbon, are less prone to breaking down and releasing heat compared to lithium ions, cobalt, or nickel-based ones. More like a chill marathoner, staying cooler. Lithium ion batteries are still used more because they're more developed and pack more punch. They have higher energy density, 150, 250 versus sodium's 150. So they're smaller and lighter, perfect for phones, laptops, and EVs. Lithium ion tech has a decades of research, manufacturing, and supply chains make it reliable and widely available. Sodium ion is catching up. It's cheaper and uses abundant materials, but it's bulkier and less proven for mass markets. Think of lithium ion as a polished sports car, while sodium ion is a rugged budget truck still being tuned. In the future, sodium ion could take over for cost sensitive like grid storage or budget EVs.
I just wanted to understand, is there any car in which sodium ion is being used?
Right now, there aren't many electric vehicles, EVs, on the market using sodium ion batteries commercially, but some are in testing. For example, a huge Chinese battery maker partnered with companies like Cherry to trial sodium ion batteries in low-cost EVs, aiming for production soon. Showcased a small EV with a sodium ion battery in 2023, targeting budget models. These are early steps. Most EVs still use lithium ion for better range and compactness. Sodium mainly being ion for affordable cars or hybrids where cost beats.
Understand the life cycle of a sodium ion battery. How many times can I charge it and discharge it?
The life cycle of a sodium ion battery, how many times you can charge and discharge it, depends on the design, but they're pretty durable. Typically, sodium ion batteries can handle around 1,000 to 3,000 charge-discharge cycles before losing significant capacity, say, dropping to 80% of original power. For comparison, lithium-ion batteries often range from 500 to 2,000 cycles, so sodium-ion can be competitive or better. Sodium's chemistry is less harsh on electrodes, so they degrade slower. Some lab tests hit 5,000 cycles with tweaks, but 1,000 to 2,000 is a safe bet for real world use.
So you are trying to say sodium ion has better life cycle than lithium ion. Energy density is little less, but that's fine. And you are explaining only the size is the matter here. Apart from that, the rest works in favor of sodium ion.
Yeah, sodium ion batteries often have a better than lithium ion, 1,000 to 3,000 cycles versus 500 to 2,000, so they last longer. Energy density is lower, 100 to 150 weight kilogram versus 150 to 250 weight kilogram, which means they're bulkier for the same power, and that's the main downside. Size and weight matter a lot for things like phones or premium EVs, where lithium ion still, but sodium ion wins on cost, cheaper materials, safety, less fire risk, and sustainability, abundant sodium. So, apart from being chunkier, sodium ion's got a lot going for it, especially for stuff like grid storage or budget vehicles. You've got a solid grasp on sodium ion batteries, but here's a couple of points you might not have thought about. 1. Environmental impact. Sodium ion batteries are greener since they use abundant materials like sodium and iron, not scarce ones like cobalt or lithium. Those can harm ecosystems, so sodium ion could be better for a sustainable future. 2. Temperature range. Sodium ion batteries can perform well in extreme cold or heat compared to lithium. Some designs work at minus 20 degrees Celsius or below without much power loss, which is great for EVs in harsh climates. They're ideal for big scale uses like solar, wind energy storage. Their lower cost and safety make them perfect for grid systems, where size matters less than reliability.
Okay, thank you so much.